Hi there. Ever heard of the fourth phase of water? Gerald Pollack, the professor at the University of Washington, would like you to hear about it. He's written a wonderful book titled that, The Fourth Phase of Water, which you might immensely enjoy. I certainly did. Everybody knows the three phases of water: ice, solid, liquid, water, running water, what we drink, and then gas, vapor, steam. What's the fourth phase? Well, the fourth phase is probably what allows life to exist on planet Earth, at least beyond a single cell organism. And here's the reason. The fourth phase is where water, which is it's H2O, but H2O is not made in a perfect line. It's actually bent a little bit. The two hydrogens are bent from an oxygen in the middle at about 104 degrees. And because oxygen is slightly negative and the hydrogen is slightly positive, in effect you get an electrical dipole or a magnet. Well, you know what happens when you take magnets. You go to the rock shop and they've got magnestones, they're magnetic stones, magnetite, and you can pick it up with long chains. Magnets hang on to each other, but the same charge repel each other. Okay? Well, water, because of that 105-degree angle, can make a hexagon. And we know it makes hexagons because UVB light at 270 degrees is absorbed by that in chemistry, and water makes that in zones called exclusion zones, or what another scientist, a friend of Dr. Pollack's, calls it the EZ zone. The EZ zone happens when you get sheets of water, which are just a couple nanometers thick, but the sheets spread out and they get another sheet on top of it, another sheet on top of it, and each one is at a 60-degree angle and they become impenetrable. But every 6 carbon layer will start having one extra electron left over, which makes that EZ zone quite negatively charged. How does that support life on planet Earth? Well, we have to have a blood system that pushes nutrients through the body. But to get through a capillary, a tiny little capillary in which a red cell is 25% larger, how does that red cell push through that capillary? Well, the red cell also has a negative charge on its surface. Get that? Negative charge on the surface, negative charge on the EZ zone of structured water, the fourth phase of water. And the red cell is repelled by that water. And now you have a virtually frictionless motion. And now combine that with capillary motion caused by the physics of an EZ zone, and you actually suck the water through the capillary. So your blood is flowing through your system, perhaps most dynamically because the capillaries are pulling it through, sucking it through, and your heart is trying to keep up. If the heart was a pump, your aorta would stretch out as the heart pumped, but your aorta doesn't stretch out, it constricts down. So when your heart's beating, the aorta doesn't bulge out, it constricts down, suggesting that your capillaries are pulling it through and the heart is keeping up. If the heart was a pump, it would have to build up tremendous pressure. Well, the apex of the heart is only one cell layer thick. If it had incredible pressure, it would burst. And that's not what the heart's doing. The heart's doing is making a swirl. So the heart is participating in making a swirling motion of blood that allows it to flow freely back so that the capillaries can push it. Isn't that an interesting proposal? Your heart isn't much a pump as it is a ramjet that's pushing it through, supplying maybe the organs, but then letting the capillaries all over your body do the pulling. Very interesting proposal. The rest of the book is a fascinating read, but multicellular life depends on the distribution of blood. And the distribution of blood depends on frictionless motion through capillaries, and that's made by the fourth phase of water. All life depends on that. That's a fun little thought. Dr. John Whitcomb for News and Nutrition. Gonna go have a glass of water.